Hello and welcome to the video deriving derivatives part 2. So today I'm going to be deriving two rules when deriving functions that we are multiplying and deriving functions which we are dividing. Okay, so let's start with the proof of the first one, the multiplying one, sorry. So you want to derive this equation. We are going to do that as usual with our famous friend the limit. We are literally just going to write this. So fg, a small nudge, so this can be thought of as x plus delta x, minus fg of the previous point, which is very close to this point. You can see my other videos where I explain this in more detail. Please check them out, or the videos on calculus. And if you know this, then you can just continue with me. So what we do here now is we can do this algebraic manipulation. F of x times g of x minus f of a times g of a x minus a. Now what we want to essentially do, we want f of x minus f of a, so that we have our x plus delta x minus f of x. The way we can do this is by introducing an f of a here, and obviously here we have f of a and g of a. So we need an f of a and a g of x, so here we're going to have a g of x for the g of a, and so we'll be able to subtract the g of x minus the g of a. So what we're going to add, maybe you've already guessed it, is minus f of a times g of x, and so that this cancels, so that this goes to 0, I have to write as well f of a times g of x, so this goes to 0, minus, it's really just a small trick, minus f of a times g of a all over x minus a. So if I just scroll down quickly, the limit as x approaches a, so x is going to a on our number line. Now let's have a look at this. So we want to separate, we have g of x here and g of x here, so we can write g of x times f of x minus f of a divided by x minus a, and we can separate this because we have a plus sign here. So we have f of a twice here, so what we'll do, we'll put plus f of a times g of x minus g of a divided by x minus a. That equals, we know this is the derivative at point A of our function f, and this is the derivative of our function g at point A. So what we get essentially is g of x times f derived x. This is Newtonian notation, Newton's notation, and f of a, sorry, this is the derivative of f of a. It's supposed to be a because the x is approaching a, so this turns into a, plus f of a times g derived of a. We can rewrite that in a much nicer form, which we all know. F of a times g of a derived, and that's it. Okay, so next up we're going to prove that this is true. I wrote it. We're going to prove this is true, basically. So how are we going to start this? So we're going to think as always, basically. It's nothing adventurous. So x plus some small nudge, and the point where we started at really close to this point. X minus a equals, we can rewrite this using basic algebra. Again, your algebra must be on point for this, otherwise you will make a mistake, most likely. And now the limit as x approaches a. You're supposed to write the limit for everything, but I don't really do that too often because I think it makes sense that we're using limits here, but just to specify it. So we have to get rid of this. So if we multiply by this, we get the top. We don't have this sort of fraction on top, which is what we don't want really. So f of x times g of a. Again, we didn't have g of a, and we're going to multiply by g of a, minus f of a times g of x minus a times g of x, and g of a. So we could rewrite this as, if we put this together, we have a common denominator, then f of x, we would have the same basically, g of x times g of a minus f of a times g of x. So that's where I got this, and then I just multiplied it by this so that I would get rid of that, and I would just have the top for me to manipulate with. So limit as x approaches a, and now we need to figure out another trick. So we want our f of x to go to the previous point, so minus f of a. We've got that here, and we want our g of x to go minus g of a. So what we're going to do is we're going to write f of x times g of a minus f of a. We need an a for this g as well, so g of a. And then we're going to have to make this 0, so what we're going to do, we're going to write plus f of a times g of a, and then we are going to write what we have before, f of a times g of x. Again, I'll give this a letter c, so all of this whole expression is going to be called c. So we need to manipulate this further, because obviously we have f of x minus f of a, we have a g minus g of x plus g of a, so what we really want to do is we want to put minus 1 in front of that, so that we get g of x minus g of a, because that's what we want. We want the x plus delta x, which is our x, just substitute this, minus our a, which is our x. Okay? So we are going to do just that. Sorry. Limit as x approaches a, and again rewriting this, all of these terms, f of x times g of a minus f of a times g of a minus, because we put a minus sign in front of the whole term, so what we are going to get is minus f of a times g of a plus f of a times g of x. Notice how the sign switched, yeah? And then c, which is this term here. So now we are going to rewrite this in a much better form. So we have g of a, again, just like in the previous proof, we have g of a here, we have f of a here, so we are going to multiply it by that. Let me see if I can go any lower. So the limit as x approaches a, we have g of a twice, so g of a times f of x minus f of a over this mess. So x minus a times g of x times g of a. That was our c. I denoted it as that. I substituted it. Minus, let's not make a mistake here, so I should have put f of a there. Just erase that quickly. So minus f of a times g of x minus g of a divided by x minus a times g of x times g of a. Now we can rewrite this in our fantastic special form. Our x is going to go into a, so below here we're going to have g of a times g of a, which is basically g squared of a, and this is going to be the derivative, and this as well, just like in the previous proof. Just look at the previous proof if this is too hard. You can really learn a lot from the previous one, it's a bit easier. So, sorry, I'm going to, that shouldn't be there. So, what we get is g of a times the derivative of f at point A minus f of a times the derivative of a divided by x minus a. X is going into a, so what we have is a minus a, which goes to 0, and we have g squared of a, and that is our term. Obviously, how we write it usually is f derived of a times g of a minus f of a times g derived of a over g squared at point A. That's the term. So thank you for watching. Please subscribe, like the video, share it with your friends, and check out my other videos on calculus. Thanks for watching.